Okay, bonds part 7. Just put the line out first because handwriting's not that great. Bonds part 7. Cool. So let's begin with another problem. I said last time we're going to try another problem. Let's try this. So let's put down all our variables. PMT per I, N, M. Sorry about that. M, I over M, and N, M. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 variables. Let's begin by saying that this bond is trading at a discount, 800, and its future value is 1,000. This time we're going to solve for the coupon rate. The question is, what is the coupon rate on this bond? So PMT nom is really what we're solving for. PMT per is, also kind of significant. We do know, however, the face value is 1,000. So, we could say that X% of 1,000, equals that, and PMT per would just be X%, times 1,000 over 2, because we'll do semi-annual compounding. Let's say it's a 7-year bond. It has a 8% yield to maturity. Periodic payment is unknown because that's what we're looking for. I over M, well, 8 over 2 is 4, and N times M is 14. 7 times 2 is 14. Okay, so as we know, once we have any type of semi-annual compounding, we don't care about the I anymore. We don't care about the N anymore. This becomes our N, this becomes our I, this becomes our PMT, this becomes our FV, and this becomes our PV, because that is the relevant information in terms of periodic. So we're solving for PMT per over here, because we're looking for X. When we're looking for the coupon rate, we're looking for this X% over here. X, what is it? So what we need to do is we need to get to PMT per, because we know that PMT not PMT per are very closely linked, and we know that because PMT nom divided by 2 equals PMT per, which therefore means that once we've solved for PMT per times 2 equals the dollar value for PMT nom, and then we'll move on from there. So let's solve for PMT per and find out what that is, and that comes out to 21.06. That's obviously in dollars, and like we said before, all we need to do is we need to double that over to get back to our PMT nom. Our PMT nom is 42.13. Okay, so we're looking for the coupon rate. The question asks us, what is the coupon rate of this bond? So this is our prime information here. We're looking for X. So X% of 1,000 equals 42.13. And what we need to do is isolate X. So X% equals 42.13 over 1,000. And obviously we know, let's just scroll here a little bit. We know that X% is X over 100, or we could just do this, equals 42.13 over 1,000, and then we'll just multiply that through by 100 to get rid of that. So X actually comes out at 4.213%, and that is the coupon rate that is quoted on this bond. So let's just scroll back up so you can have a look at the problem in its entirety, and let's just write over here X equals 4.2%. That is the coupon rate that was quoted on this bond, and that's really it. That's all there is to it. That's the hardest it can really get. Everything else is just plugging in. If you follow follow this 9-step method, you'll never ever ever get any question wrong. Just follow the method. Don't take shortcuts. Don't think, oh yeah, of course m's always 2, so I'll keep it in my head. Or no, n is 10, and 10 is a nice round number, I'll keep it in my head. No, don't keep anything in your head. Write it all out. PV, FE, PMT non, PMT per, I, N, M, I over M, NM. It should be very, 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 very quick to recall all of these variables. Should be on the tip of your tongue. Okay, next. Something that we need to do is current yield, which is another way of evaluating bonds, and we also need to think about the capital gains yield. Let's write that down. Capital gains yield, and this is a favourite in Mel's class, and quite rightly so. These are, it's kind of nice when professors test you on things that are relevant, because a lot of the time you find yourself memorizing information which is completely useless. But the reason why you test on this is because it's actually important. Let's just abbreviate current yield to CY, and we're going to abbreviate capital gains yield to CGY. Now, the important thing that to note here that really links CY and CGY together, and I'll explain soon what they are, is the following. The yield to maturity, i.e. the total return on holding a bond over a certain period of time until its maturity, is equal to the returns that you get from the current yield and the capital gains yield, which is the return that you get simply from appreciation in the value of the bond. And that's really what links these together. Now, current yield, what is it? So this is the way to calculate it. YTM, we know how to calculate. We've spent at least a video and a half, perhaps even 2 full videos on really understanding yield to maturity and how it's calculated. Current yield is calculated by doing the PMT nom, which is why I like to have the PMT nom and the PMT per down separately, over here, because once we have the PMT nom and the PMT per down separately, the PMT nom is relevant information for calculating the current yield, so that's why it needs to just sit there by itself, in its own little slot. Now, PMT nom divided by the present value, and that is all there is to it. The current yield is the annual interest payment on a bond divided by the bond's current price. A brokerage house, will report on bonds. They often refer to the current yield, and unlike the yield to maturity, the current yield doesn't represent the total return. The yield to maturity represents the total return, including the capital gains yield. But it doesn't take into account that capital gain that will be realised if the bond is held until its maturity, or until it's called, of course. However, it does provide some information regarding the amount of cash income that will be generated in a given year, but it doesn't really give an accurate measure of the total expected return. So all you'd have to do over here is take the PMT nom and divide it by the present value. So let's scroll up and take the current yield of the bond that we were dealing with here. So the PMT nom is 42. Let's just scribble down current yield equals 42.13. Always dollar values divided by the present value, which is 800, and that equals 0.053, and that's 5.3%. That's our current yield. Now, our yield to maturity here, I, is 8. So let's scroll down. Yield to maturity is 8%. Our current yield is 5.3%. Here's a question. What's the capital gains yield? Well, it's just 8% minus 5.3%. All you need to do is just flip this around. 5.3%. So let's just scroll a little, and that comes down to a capital gains yield the total 8% return, 5.3% of the return that was made by the investor on holding this bond came from current yield, and 2.7% of it came from the capital appreciation, the capital gains that were realized because the bond was held until its maturity. And that really brings us to the end of our discussion on bonds.